Hi, in this video we are going to go over the solution of the problem 206, reverse a linked list. So I have the class node here, and then I defined my linked list here. First I define the nodes with the value for them, and then I define how these nodes are connected to each other. And after defining that, so we get this linked list. So we have A, B, C, D, E to the noun, and we have value for each one, and the goal is to reverse this and to get to this one. So here head is 5 and it goes in a reverse direction until we have noun referred to the previous head, which right now is the last node in the new linked list. So imagine that I have a function that is like this called reverse list. So input to that is head of the list, and just for now I'm returning head to be able to print it out. And I'm also going to print that in a kind of a nicer format, so I'm using just a print function in a clean format. And if I run that, so this is my linked list 10, 12, 8 to 5 to none, and after implementing the function, which is this one, so I'm going to use the node A, because node A here is the head of the linked list. So I put that as an input to the function, and I get the capital head here, and I'm going to print that as a reverse linked list. For now, there should be those things should be identical because we did nothing inside the function. We just printed out the same thing. So this is the original and this is the reverse. Now let's fill out the function and see how we can solve this problem. So okay, for doing that, the first thing that I'm going to do is that I need a none here at the end, because this 10 should refer to something. So let's give the value and define that, and I'm going to call the value called prev, so for as a short for previous, and I'm going to call that none. Okay, and then I'm going to do something like this, and I'm going to say this node here, I'm going to call that what CURR, it stands for current. I'm calling that for current, and I'm going to say that is the node A. Node A at the beginning is the head. So when head comes here, so I put that in the current, and I said, oh, okay, the previous one was none. Now I'm going to go and say I should go one step forward in a linked list, and for doing that I have a while loop and say, as far as I have the current, I say next node equals current dot next, because if this is current, current dot next is this one, and then I come and say new current for the next node equals next. Okay, so just to be clear, instead of just putting this directly into that, because we are going to use a temporary variable next node, because we don't want to overwrite that current. So we need that, so this is just doing nothing. It's just a temporary variable to record the next node, but I don't want to just directly substitute current.next to current, because I have two more steps here, and if we do that we are not going to get the correct results. So after doing that, what I'm going to do is that I'm going to say I have to show that reverse direction. So for doing that, I'm going to say here that my new current dot next is my previous. Do you remember here we had previous? So that is going to be our current dot next. So if current is here, it's current dot next, new current dot next is previous. So that goes there. The next thing that I'm doing is that for this previous that we had here is also needs to go one step forward in the while loop. So for doing that, I'm going to say new previous equals current, because this is current right now. The new one, the next previous in the next loop needs to be that. So if we do that, and at the end this previous will end to be here, to the new head. Why? Because the current here will be the next node. Next node is the current.next, which will be none. So current will be none, and before that the previous will be the last node. And because of that, we are going to return the previous as the new head. So let's do that and see what we can get. Okay, so we had originally this linked list, and we just reverse that to this. So now 5 to 2 to 8, 12, 10, and none. Okay, now I put some printing functions here to at the end of each line to just have a better understanding of the algorithm. So and because sometimes those variables could be none, so I have to use if a statement. If that variable that I'm just printing is none, I just is not none, I print the value. If it is none, I just print none. So by having that printing function, we get this one here. So this is my original things, and let's go over that to see what we are doing. So the current.next is this one, 12, and current.next is going to be recorded in a next node as a temporary variable here. My previous variable, what is that? That is none. That is here. So that one is going to be my new current.next, because we are going to refer to that. Okay, and then we have the previous here equals current equals 10, because we are going to move previous one step forward, because next time we need that. Also, we substitute the next node to current to move one step forward. So next node to current, so now current is 12. In the next loop, the current.next will be 8, because current is 12, current.next, and so forth. So if we do that, by the end of that, we get the reverse linked list. Okay, the time complexity of this problem is order of n, because we are going to visit each node once, and the space complexity is O of 1, because we are not creating any array or anything like that. Thank you so much for watching this video.